Welcome to Metrology lecture series. In the present video, we will discuss the standards of measurement. First, we have to look for the what you mean by standard. A standard is a rule made by an authorized body to measure the things like quantity, weight, size, value, or quality in the same way in the everywhere. So role of the standards is to support the system which makes the uniform measurement throughout the world and also helps to maintain the interchangeability in mass production. So in this regard, we have to maintain the same systems of measurement. First we have to see the what are the systems of measurement. So system of measurement is a measuring system based on few fundamental units like length, mass, type, temperature, etc. All these physical quantities can be expressed in the terms of these fundamental units. And the following systems of measurements are used in different countries. First system of measurement is the FPS system. In this system, unit of length is yard, unit of mass is weight, or force is the pound, unit of time is seconds, and unit of temperature is the degree Fahrenheit. This system being inconvenient and steadily losing its popularity. Second system is the metric system. Metric system is the predominant system in the world. It is a decimal system of weight and measure, and it is based on meter as a unit of length, kilogram as the unit of mass, and kilogram force as the unit of weight or the force, and unit of temperature is the degree centigrade. And this metric system is very simple for the calculation purpose than the FPS system. So next third one is the SI system. This system is extension and refinement of the metric system. It is more convenient and superior to the other system. This system, like traditional metric system, is based on the decimal arithmetic, and it provides only one basic unit for each physical quantity. And SI system is the compressive because its 7 basic units cover all the disciplines. This table shows the basic quantities and its units in the SI system. First quantity is the length and its unit is the meter and symbol is the M. So for the time, unit is the second, its symbol is the small s. For the mass, unit is the kilogram, symbol is the kg. For the temperature, unit is the Kelvin and symbol is the capital K. For electric current, unit is the ampere and symbol is capital A. And for the luminous intensity, unit is the candela and symbol is the CD. And quantity of substance, unit is the mole and symbol is the MOL. Next we will discuss the measurement standards. An ISO is responsible for establish the standards and maintaining the standards, and also responsible for the calibrating and other secondary tertiary standards by comparing these with primary standards. Measurement standards are the different kinds of standards like material standards and the wavelength standards. So first we have to see for the material standard. Material standard is a material to measure or measuring system intended to define, realize, converse, or reproduce a unit or values of a quantity to serve as a reference. So in the material standard, so with respect to the material, we have to considering the reference to the defining or reproducing and converse the values of the quantity. Next we will discuss the different types of material standards. There are the two types of material standards. First one is the line standard. Second one is the end standard. First we have to discuss about the line standard. In the line standard, line is a fundamental physical quantity which plays a major role in our daily life as well as in trade and manufacturing system. So in the line standard, with respect to the line, we have to measure the fundamental physical quantity. According to the line standard, yard or meter is defined as the distance between the scribed lines on a bar of a metal under certain conditions of temperature and support. These are legal standards and Act of Parliament authorizes their use. So first we have to discuss about the yard. Imperial standard yard is a bronze bar and its composition is 82% of the copper, 13% of tin and 5% of the zinc, and its cross section is the 1 inch square cross section and 38 inches long. And the bar has the 2 half-inch diameter and 2 half-inch deep holes. This is the schematic representation of standard yard. Standard yard is made of bronze bar. Its cross section is 1 inch and length is the 38 inches. And also we can observe there are the 2 half-inch diameter holes with the half-inch depth, and the distance between these two holes is 36 inches. Moreover, each hole is fitted with the 1/10 inch diameter gold plug, and also top surface of these plugs lies on the neutral axis of bronze bar. So yard is then defined as the distance between these two central transverse line of the plug at the 62° Fahrenheit. The purpose of keeping the gold plug lines at neutral axis is that due to bending of beam, neutral axis remains unaffected. Secondly, the plug being in a well is protected from the accidental damages. So the purpose of these gold plugs is due to bending of the bar, neutral axis should not to affect. Moreover, these gold plugs are protected from the accidental damages. In order to minimize slightest error in neutral axis due to support at ends, the supports must be placed such that the slope at the ends is 0 and the flat ends faces of the bar are mutually parallel, which is as shown in the figure. In general, maximum bending occurs at the middle of the bar when the supports are at the ends. In this regard, minimize this issue, supports should be at the respected points, that points we are calling as the Airy points. So Sir G.B. Airy showed that this condition was obtained when the distance between the support is 1/root of n square minus 1 into capital L, where n equal to the number of supports and L equal to the length of the bar. So for a simply supported beam, the expressions become So 1 by root of n square minus 1 into L become the, here 2 supports, then n equal to the 2, then 1 by root 3 into L, which becomes the 0.577 L. So these points of support are known as the Airy points. So have to maintain the 2 supports at the distance of the 0.577 L. Next we will discuss the standard meter. This is the schematic representation of the standard meter. Here we can be observe shape of the standard meter is the hinged section and dimensions are the 16 mm in the width and 16 mm in the depth. Moreover, we can be observe neutral axis is lies on the web surface. Moreover, this standard meter is made by the platinum iridium alloy. So the section chosen gives the maximum rigidity and economy of the costly material. Also the neutral axis lies at the top of the web and therefore it can be graduated. Overall width and depth are the 16 mm each. This is the distance between the center portions of two lines engraved on the polished surface of a bar of pure platinum and iridium alloy. The bar is kept at 0 degree centigrade and under normal atmospheric pressure. It is supported by 2 rollers having at least 1 centimeter diameter, which are symmetrically located in the same horizontal plane at a distance of 751 mm from each other, such that there is the minimum deflection. The meter line is quite stable and international yard as adopted as 1 yard equal to the 0.914400 meter or 1 inch equal to the 25.4 millimeters. Next we have to discuss about the end standards. In the end standards, length is expressed as the distance between the two flat parallel faces. It is known as the end standard. So examples of the end standards are the slip gauges, end bars. So the end faces are hardened, lapped flat and parallel to a very high degree of accuracy. Use of the line standard, it is very difficult at various places in workshops. Hence the end standards have been established. End standards are used for all practical measurement in workshop and precision engineering laboratory. So these end standards are in the form of end bar and the slip gauges. So first I have to discuss about the end bar. So this can be called as the length bar. So these end bars are used for the measurement of larger sizes of the workpieces. These end bars are consist of the carbon steel round bar about the 20 mm in diameter and made in sizes varying from the 10 mm to 1200 mm length. There are hardened only at the ends up to the 800 HV and supported at airy points so that end surfaces are parallel to each other. These are also available in the 4 grades of accuracy. First one is the for reference, second one for the calibration, third one for the inspection and fourth one is the workshop. Next we will discuss the another type of end standard, that is the slip gauges. Slip gauges are practical and end standards used in linear measurements. Slip gauges are the rectangular blocks of hardened and stabilized, and these are made by the high graded steel or zirconium oxide. Slip gauges are having the 9 mm width and 30 to 35 mm long cross section. The length of the slip gauges is the dimensions with it measures. These are hardened to resist wear and stabilized to relieve internal stresses. These slip gauges are the made as per IS 2984-1981 and IS 2984-2003 standard. So next we have to discuss about the characteristics of the line standards. So in the line standards, when the length is measured as the distance between the centers of two engraved lines is called as the line standard. So in the line standard, both material standards, yard and meter, are the line standards. Most common example of the line standard is the steel rule with divisions shown as lines marked on it. So the characteristics of the line standards are the scales can be accurately engraved, but the engraved lines themselves possess the thickness, so it is not possible to take the measurement with high accuracy. So high accuracy is not possible with the line standards. Scale is a quick and easy to over a wide range. So with the help of the line standards, we can measure the dimensions very quick and also easy. The scale marking are not subjected to wear. However, leading ends are subjected to wear, and this may lead to undersize measurements. A scale does not possess a built-in datum. Therefore, it is not possible to align the scale with the axis of measurement. Scales are subjected to parallax error. Moreover, the assistance of magnifying glass or microscope is required if sufficient accuracy is to be achieved. So these are the characteristics of the line standard. Next we will discuss the characteristics of end standards. In the end standards, length is expressed as the distance between the two flat parallel faces. So example, measurement by slip gauges at the end bars and ends of the micrometer anvils and vernier calipers, etc. The end faces are hardened, lapped flat and parallel to achieve a high degree of accuracy. Next we have to look for the characteristics of end standards. These end standards are the highly accurate and used for measurement of close tolerances in precision engineering as well as in the standard laboratories, tool rooms, inspection departments, etc. So there are required more time for measurement and measure only one dimension at a time. And these end standards are the subjected to wear on their measuring faces. So group of slips can be rung together to build up an given size. Faulty ringing and careless use may lead to inaccurate in the results. So ringing and careless may be causes for the inaccuracy in the measurement. End standards have a built-in datum since their measuring faces are flat and parallel and can positively lock on datum surface. These end standards are not subject to parallax error as their use depends on the field. Next we will discuss the line standard versus the end standards with different characteristics point of view. First one is the principle. In the line standard, length is expressed as the distance between two lines. In the end standard, length is expressed as the distance between the two flat parallel faces. Accuracy point of view, line standard is limited to plus or minus 0.2 mm for high accuracy, and moreover scales have to be used in conjunction with magnifying scale or microscope. Accuracy point of view, end standards are highly accurate for measurement of close tolerances up to plus or minus 0.001 mm. And ease and time of measurement point of view, line standard measurement is quick and easy, but end standard, use of end standard requires the skill, and moreover it is the time consuming process. Next, effect of wear point of view, in the line standard, scale marking are not subject to wear. However, a significant wear may occur on the leading edges. So, it may be difficult to assume 0 of the scale as I datum. So, in the end standard, these are subjected to wear on their measuring surfaces. Next, alignment point of view. So, in the line standard, cannot be easily aligned with the axis of measurement, but in end standards can be easily aligned with the axis of measurement. So, manufacturing cost point of view. So, line standards are the simple to manufacture and with the very low cost. Same in the end standards point of view, manufacturing process is the complex and it is the cost is very high. So next, to parallax error point of view. So line standards are subjected to parallax error, but end standards are the not subject to parallax error. So examples of the line standards are the scales or yard and also meter. So end standards examples are the slip gauges, end bars, vernier caliper, micrometer, etc. So these are the differences between the line standards and the end standards with the various characteristics point of view. So next we have to discuss the wavelength standard. So the main drawback of the material standards such as the meter and yard is their length changes slightly with respect to the time. Moreover, consider difficulty is experienced while comparing and verifying the size of the gauges by using the material standards. So these are the causes of error of unacceptable order of magnitude. So it therefore becomes necessary to have a standard of length which will be accurate and invariable. In this regard, Jacques Babinet, a French philosopher, suggested that the wavelength of monochromatic light can be used as natural and invariable unit of length. So in the wavelength standard, meter is defined as the length of the path travelled by light in vacuum in 1 by 29, 97, 92, 458 seconds. According to this, standard meter was defined as the equal to 165.0763.73 wavelengths of red orange radiation of krypton isotope 86 gas. So the meter and yard were redefined in the terms of wavelength of orange krypton 86 radiation as 1 meter equal to the 165.0763.73 wavelength and 1 yard equal to the 0.9144 meter equal to 0.9144 into 1650763.73 wavelength. So 1 yard equal to the 1509458.3 wavelengths. So next we have to compare the advantages of the wavelength standard with the material standard. So wavelength standard is not a material standard, hence it is not influenced by effects of variation of environmental conditions like temperature, pressure, humidity and the aging. Moreover, wavelength standard need not be preserved or stored under security, and thus there is no fear of being destroyed as in case of the meter and yard. And it is not subject to destruction by wear and tear. Moreover, wavelength standard gives a unit of length which can be produced consistently at all the times in all the circumstances at all the places. So in the other words, it is easily reproducible and thus identical standards are available with all. This standard is easily available to all standardizing laboratory and industries, and there is no problem of transferring this standard to other standards, meter and the yard. Next we will discuss the subdivision of standards. There are the standards are subdivided into the 4 grades, that is the primary standards, secondary standards, tertiary standards and the working standards. First we have to discuss about the primary standards. For the precise definition of the unit, there shall be one and only one material standard, which is to be preserved under the most careful conditions. So it is called as the primary standard. So international standard and the international meter are the example of primary standard. So primary standard is used only at rare intervals solely for comparison with the secondary standards. So in general we are not using the primary standards for the general purpose. So using of the primary standard is comparison purpose with the secondary standards. So it has the no direct application to a measuring problem encountered in the engineering applications. So next one is the secondary standards. So secondary standards are made as nearly as possible exactly similar to the primary standards. So as regards to design, material and length point of view. So secondary standards are the compare with the primary standards after long intervals and they record the deviations. These secondary standards are kept at a number of places for safe custody. Secondary standards are the used for occasional comparison with the tertiary standards whenever required. So third one is the tertiary standards. So primary and secondary standards are applicable only as ultimate control. Tertiary standards are the first standard to be used for reference purposes in the laboratory and the workshops. So tertiary standards are made as true copy of the secondary standards. They are used for the comparison at intervals with working standards. So next we have to look for the working standards. Working standards are used to more frequently in laboratory and workshops. They are usually made of low grade of material as compared to the primary, secondary and tertiary standards for the sake of economy. So there are divided from fundamental standards. Both line and end standards are also using in the working standards. So line standards are the made from H cross sectional form.